Are you a beginner in the software industry? Do you wish to crack the most brain-teasing data structures and algorithm questions to land in your dream company as a software developer? Then you are at the right place. These top 10 data structures and algorithm-based interview questions are asked most frequently in major MNCs. This quick session on data structures and algorithm questions will keep you on a safer side while attending the interviews of your dream company. Data structures and algorithm questions play a vital role in every software development interview. They have become essential to crack by every software engineer to get hired by the top tech companies like Accenture, TCS, Infosys, Amazon, and many more. Before getting started, let me know which is your dream company. You can let me know in the comment section below. Hey guys, welcome to Simplilearn. Today we'll be learning the top 10 DSA interview questions and answers. And while we are at it, please leave us a like if you find our content helpful, and a sub to the channel would be appreciated. So without any further delay, let's get started. And the top 10th question is, consider a text file interrupted by a bug, and all the text has been reversed due to this bug. So which data structure would you choose to implement a program to revert the text file to its original? The solution is stack data structure. Let's look at the problem. We must rearrange the string element by element in reverse order. Sounds something like last to first. As we all know, stack follows first in last out principle. In order to reverse a string, we must create an empty stack to push all the string characters one by one, and then pop out the character one after the another. So once performing the pop operations on a string, all the string characters would be reversed and form into the original string. Now let's try to implement the program using stack data structure. So as you can see here, we have a reverse function which is declared, and going to the function, here we have a structure of stack where we have top, size, and array variables, and we have a function called stack creation. So first we are allocating memory to a stack using malloc function, and the size is assigned to stack of size, and initially stack of top is equal to -1, and then allocating memory to the stack of array. Then coming to is full function where it checks whether the stack is full. So if full, return stack of top is equal to stack of size -1, and checking if the stack is empty, that is empty, return stack of top is equal to -1. And then coming to the push function, which is used to insert the item into the stack. So it checks if the stack is full, return where the item is assigned to stack of top, and pop to delete the item from a stack. So it checks if is empty, then return int min, else return stack of array, that is of stack of top -, that means stack is empty, else decrementing a top by -1. And then coming to the reverse function, here we have string length of string which is assigned to n, and then calling the stack creation function to create an empty stack, and from I is equal to 0 to n, push all the stack, whatever is there in the string of I is pushed to the stack, and for I is equal to 0 to I less than n, pop all the items to back to the string of I. And then coming to the main function, here we have a reverse string, and here we are reversing a string. So we are calling the reverse function, which is this, and it tries to reverse this string and get back to its original form. So it prints the reverse string. So let's try to execute it. So as you can see here, reverse string is Simplilearn. The top 9th question is, consider you have been assigned a task in which you are given an array of numbers to be arranged in ascending order. So which sorting algorithm would you choose to place the numbers most efficiently? And the solution is quicksort algorithm. Quicksort algorithm helps to search the information faster than any other sorting algorithm. It is widely used to sort the elements faster. Also, memory storage is utilized efficiently since no additional storage is required. If the array size is small, then the quicksort algorithm works faster to sort the elements. So now, let's consider array of elements 3, 5, 2, 4 and 1, and let the pivot element be 3. So, why are we taking pivot as a 3? Because the left hand side element is greater than the right hand side element. So, if the right side element is lesser than the pivot element, then swap out the elements. Next, comparing the next left element with the pivot element, and it checks whether 5 is lesser than the element 3. So if it's lesser than, it will swap with each other. Similarly, comparing the next element 2, and since 2 is less than 5, it will remain in the same position. Next, comparing the element 4 with 5. Again, 4 is lesser than 5, so it will remain in the same position. So now, as you can see, the left hand side elements are not at the proper position. So considering the left hand side elements, we will swap the elements. So here, it compares 1 and 2. Since 1 is less than 2, it will remain in the same position. Next, compare 3 and 2. Here 3 is greater than 2, so it will swap out the elements. Now let's have a look at the program implementation. So here, as you can see, we have a quicksort algorithm function declaration, and then going to quicksort algorithm function, here we have array of size 24, int of left and int right. So initializing the variables I, j, p and temp. So if left is lesser than right, then assign the left element to p, that is pivot element, and assign all the left element to I and right element to j. So while I lesser than j, while array of I lesser or equal to array of p and I less than right, then increment I by 1. While array of j is greater than array of p, then decrement j by 1. So if I is lesser than j, then we are doing swap. So we are swapping the elements. That means array of I is given to the temp variable, and whatever is there in array of j is assigned to array of I, and the temp variable is assigned to array of j. And then changing the p, that means the array of p is assigned or stored in temp variable, and whatever is there in array of j is given to array of p, and whatever is there in temp is given to array of j, and then calling the quicksort algorithm. So coming to the main function, here we have I, count and array of size 25. So it's first asking to enter the number of elements. So suppose you want to enter 5 elements to arrange in the ascending order, then enter 5. So once you enter 5, it will ask to enter one element by element. So from 0 to count, it will ask 1 by 1. So then we are calling the quicksort algorithm to sort the elements, and then it will print sorted elements from I is equal to 0 to I less than count. It will sort the elements one by one. So let's execute the program. So here enter the number of elements. So let's enter 5 and enter the elements one by one. 5. So we have 2, 5, 6, 3 and 1. So the elements are sorted. 1, 2, 5, 6 and 31. Top 8th question is, you are given a list of numbers to find the minimum and maximum numbers. Implement a C program using the appropriate type of data structure. And the solution is array data structure. The array data structure is used to store multiple data of the same type, easily allowing random access to an element using the index number. It also improves performance remarkably as it stores the element consecutively. Next, the array uses less memory space as there is no usage of pointer variables. So now let's implement a program to find the smallest and largest element. So here we have array of size 50, then variable I, n, and variable to find the largest element, and a variable to find the smallest element. So first enter the number of elements. Input the array elements. So one after the other from I is equal to 0 to n, it will take the array element. And initially the largest element and smallest element is assigned to array of 0. And then coming to for loop, where for I is equal to 1 till I less than n, if array of I is greater than array of large element, Then assign array of I to the largest element. If array of I is lesser than smallest element, then assign array of I to the smallest element. And then print the smallest element and largest element. So let's execute it. So enter the number of elements. Let's enter 5 and input the elements. Let's enter 2, 5, 10, 6, 1. So as you can see, the smallest element is 1 and the largest element of an array list is 10. The next top 7th question is, let's assume you are given a task to store a set of elements with two conditions. First, memory resources drawn should be concise. Second, the data structure should be dynamically stable when new elements are added or existing elements are deleted from the data structure irrespective of the location. And the solution is singly linked list. Lists are not predefined data structures. They are dynamically programmed data structures and utilize the memory blocks from the heap storage. This makes them a viable alternative to the array as the memory needed is judiciously used. Also, whenever an element is deleted, its memory block will be returned to the heap. In a singly linked list, we can access the element easily because of the pointer variable that points to the address of the next node in the list. So here, let's understand the program implementation. So here we have a structure of a node where we have a data variable and a pointer variable called nextPTR. We have a function declaration of a node creation, node count and print list. So going to the node creation function, here we are creating a new node where we are allocating memory for it. We have a variable called data and I. So it first checks if node is equal to null, then memory cannot be allocated. Else, enter the data for the node 1. So it takes the data. So data is assigned to node's data part and initially the node's next pointer is assigned to null. So the node is assigned to PTR. Next, for I is equal to 2 to I lesser or equal to n, whatever it creates a new node, allocate memory for it and check if new node is equal to null, then memory cannot be allocated. So break. Else, enter the data for the node. That means the data is assigned to the new node's data and the new node's next pointer is equal to null. And then new node is assigned to pointer's next PTR and next pointer's next PTR is assigned to PTR. Then coming back to node count. So this function is used to count the number of nodes in a list. So initially the count value is equal to 0 and we have a structure pointer PTR. So that node is assigned to PTR while PTR not equal to null, increment count by 1 and PTR next pointer is assigned to PTR and return the count. Next, coming to the print list, that means it lists out all the nodes. So we have a pointer and if node is equal to null, that means no data found in the list. Else, the node is assigned to PTR while it checks the condition PTR not equal to null, then print all the node data. So PTR's next PTR is assigned to PTR. So now let's try to execute it. So enter the number of nodes. So if you want 5 nodes, so enter the data. So let us enter 1, 2, 3, 4 and 5. So as you can see, the singly linked list elements are 1, 2, 3, 4 and 5 and the total number of nodes are 5. Executing in this session and the question and answers we are discussing will be attached in the description box below. So you can have a look at it and execute the code for a better understanding. And if you face any issues while executing the programs, then please let us know in the comment section below and our team of experts will be happy to resolve all your queries at the earliest. The top 6th question is, assume you have stored the elements randomly in the memory. That means not contiguous. The memory elements are not stored in adjacent location memory blocks. And suppose you want to remove the elements from a given position. Which type of data structure would you recommend for such a task considering minimum traversal to save time? The doubly linked list is the clear solution as the question clearly mentions the memory blocks located are not adjacent. Now, the second puzzle is about the minimum traversal. Out of all the variants in the linked list, the doubly linked list is a viable option as it has the bidirectional traversal feature. A doubly linked list allows you to traversal in both directions, since it uses two pointers to point to the address of the previous and next node. It is easy to access the node using the previous pointer and delete the node from the list. And here we have the memory representation. So here, let's understand the working of programs implementation. So we have a structure of node, and we have a variable called data and a pointer variable previous and next. So first, coming to the insertion at beginning. So we are inserting the element. So we are creating a new node and allocating memory using malloc function. And then we are assigning a data to a new node. And the new next part is holding the head, and initially the new previous is assigned to null. So if head is not equal to null, then head's previous is equal to new, and new is assigned to head. Then coming to the void insertion at end. So inserting an element at the end of the list. So here we are creating a new node and allocating memory to it using malloc function, and the last node is equal to head. That means head is assigned to the last node. And then the new data, that means a new data is assigned to a new node's data part, and the next is assigned to null. And we are creating a temporary variable where head is assigned to temporary variable and checks the condition. If head is equal to null, then null is assigned to new node's previous part, and new is assigned to, that means a new node is assigned to head return. And here we are using a temporary variable. While temp next is not equal to null, then temporary variable nodes like next part is assigned to temp, and new is assigned to a temp's next, and temp is assigned to new's previous. And coming to insertion insertion after node. So we are specifying the position here. So if previous node is equal to null, then the given previous node cannot be null. Again, creating a new node and assigning a value to it. And now previous node's next is assigned to new next, and new node is assigned to previous node's next. The new previous is equal to previous node. So if new node's next part is equal to null, then new node's next node's previous is assigned to new. And then coming to the deletion of a node. That means how to delete a node. So first, if head is equal to null or node to be deleted is equal to null, then return. If head is equal to node to be deleted, then node to be deleted next part is assigned to head. This if condition, node to be deleted next part is not equal to null, then assign node to be deleted previous to node to be deleted next node previous. And then if node to be deleted previous is not equal to null, then assign node of next to the node to be deleted previous node's next, and free the node to be deleted. And this display function will display all the elements in a list. And then coming to the main function, we are inserting value to a node, that is 5, 2, 1, 5 and 3. 4, 2, 1, 5, 3. It print the linked list element, that it display all the elements. And then after deleting an element, so we are deleting an element heads next to next, that means fourth element, and display the head. So we are displaying the element after deletion. So let's execute it. So as you can see, we have inserted the elements 1, 2, 3, 4 and 5 into the list. So after deleting an element, that is we are deleting the fourth element. So after deleting fourth element, we got the list is 1, 2, 3 and 5. So fifth question is, you are given a problem and you need to devise a solution. The task is to build a job portal website, and the problem is that the portal needs to pick the latest profile listed on the website. So, which data structure could fit in and solve this puzzle, and how? Solution to this problem is stack data structure. We can use stack as it follows last in, first out, and the latest profile would obviously be the last item to get in and the first item to get out of the stack in a linear data structure. The items in a stack are stored in the order of the first in last out or last in first out. So, stack performs operations like push and pop, where push is used to insert the item into the stack, whereas pop is used to delete the item from the stack. Operations like insertion and deletion of an items are possible only from the one end of the stack, that is on top of the stack. So this program is to insert items into the stack and then delete the top item from the stack. So here we have a structure of stack and we have a variable called top, size and array. We have a function declaration at the top. Then going to the stack creation. So this is stack creation function where we are creating a stack and allocating memory to it using malloc function and assign size to the stack of size, and initially stack of top is equal to -1. That means stack is empty. And then the stack of array is assigned, that means memory is allocated, and return stack. Then check whether the stack is full. So using is full, check return stack of top is equal to stack of size -1. That means the stack is full. If the stack is empty, then return stack of top is equal to -1. That means stack is empty. Then push function is used to insert item into the stack. So it checks if it is full, return, else stack of A. That means the item is assigned to the top of stack. And then pop is used to delete the item from a stack. So it checks if the stack is empty, already empty, then return, else decrement the stack of top by -1. And coming to the main function, here we are calling the stack creation. So we create a stack and then push the items into the stack. We are pushing the item 10, 20 and 30. So the last element to get in is 30. So the first element will be popped out is 30. So now let's run the program and see the output. So as you can see, the first element was 30. So it is popped out. The top fourth question is, given a tree, you have to find the prefix expression of a tree. So which order of traversal would you choose? The solution is pre-order traversal of a tree data structure. So basically in pre-order traversal, we traverse a tree from the root node to the left subtree followed by the right subtree. So it is a quick way of searching and can easily get the prefix expression. So as you can see, this program is to perform the pre-order traversal of a tree data structure. So here we have a structure of a node and we have a data variable. Then we have a pointer to the left node and right node. So first, going to the creation of a new node, we are creating a node and initializing memory for it. That means allocating memory using malloc function and assigning data to a node's data part, and initially the node's left node and right node is null. Then return the node. Then coming to display pre-order function, here it tells how to do the traversal, that is first from the left node and then going to the right node. So it checks the condition. If node is equal to null, then return, else print the node data. So first display pre-order, we are calling the display pre-order function to display for left node first and then the right node. So coming to the main function, here we have a root node, values assigned 10, and root's left node values assigned 20, and root right node is assigned the value 30, and then root's left node is assigned 40, and root's left node's right node is assigned 50. Next, print the pre-order traversal of a binary tree. So calling the display pre-order function to display all the nodes. So let's execute it. So as you can see, the pre-order traversal of a binary tree is 10, 20, 40, 50 and then 30. Because 30 is the right child and 10 is the root child, whereas these are the left child. The top third question is, let's assume that you receive a software requirement that offers ticket booking services. Your job is to devise a solution that stores all the booking requests and responds to the request based on the first come first serve approach, which is the most variable and dynamically stable data structure. The solution is queue data structure. The queue is a linear data structure that follows the FIFO order, and it also a dynamically designed data structure. Queue follows FIFO, which stands for first in, first out, or in other words, first come, first serve. In queue, the elements are inserted from the back of the queue, called NQ. And the elements can be removed from the front of the queue, called DQ, as shown in the below diagram. So in this function, we have a size of 50, and we have a function called NQ, display, and the variables array of size, and initially rar and front is initialized to -1. That means the queue is empty. And next we have a while condition. So we print the choice options, that is, first is NQ operation, second option is display the queue list, and third operation is exit. And then enter your choice of operations to perform. So it's asking you to enter the choice. So if you enter 1, case 1, that means it calls the NQ function. If you enter case 2, that means it's calling the display function. And in case 3, it calls the exit function. By default, if you print any other option, then it will display incorrect choice, return 0. So coming to the NQ function, which is used to insert the item or element into the queue. So creating a new item. So if rar is equal to size of -1, that means the queue is overflow. Else, if front is equal to -1, that means queue is empty. Then assign front is equal to 0, and it's asking to enter the element to insert into the queue. So if you enter the new item, then it will increment rar by 1. That means rar is equal to rar plus 1. So now new item is inserted into the array, list of queue. And then coming to the display function, we have the condition if front is equal to -1, that means the queue is empty. Else, from I is equal to 0 till I lesser or equal to rar, it will display all the array elements. So now let's run the program. So here enter the choice, let's enter 1 and enter the item 20, and enter the second choice, that is 1, enter the item 30, and now enter 2, and as you can see the list of items are 20 and 30. Top second question is, Rahul has a large army. He arranges them in an arbitrary order, and everyone is given an integer ID. So now Rahul wants to add one army in the beginning. Now use a single pointer variable, and it should be possible to traversal in both directions. Implement a program to solve the problem statement. And the solution to this problem statement is circular singly linked list. A circular singly linked list is to perform a reverse traversal with less memory usage than a doubly linked list. We require extra memory for the previous pointer in a doubly linked list. So when we compare the circular linked list with both singly linked list and doubly linked list, we don't find a null in any of the nodes. Instead, the last node's next pointer holds the address of the first node. So basically, there is only one pointer variable in the circular singly linked list. So in this program, we have a structure of node and then variable data, and we have a single pointer variable called next. So to insert to the empty list, we are checking the condition if head is not equal to null, then return head. Else create a new node, allocate memory for it, and assign a data to the new node's data part, and new is assigned to head, and head is assigned to head's next, return head. And then insert at beginning. So if head is equal to null, return insert to empty list. So again create a new node, allocate memory, and assign data to the new node's data part, and head's next is assigned to new next, and new is assigned to head next, and return head. And coming to the void display function, so it displays the list of elements. So it checks we have a pointer variable ptr, and it checks if head is equal to null, that means the list is empty. So it will return. And then the head's next is assigned to pointer, and here we are using do while condition. First it prints the data part. So pointer next is assigned to ptr, and then checks the condition while, that is pointer not equal to head of next. And coming to the main function, We have assigned null to the head, and we are inserting element at the beginning of the list, 30, then 40 and 10. So then print listed elements, linked list elements are, and we're calling the display function. So this function will display all the elements. So let's run it. So as you can see, the linked list elements are 10, 40 and 30. The top first question is, given a tree, you have to count the number of nodes in a tree. Create a function and try to call the function inside the same function. And the solution is tree data structure. A tree consists of a root node, followed by parent node and a child node. So this program is to count the number of nodes in a tree. So here we have a structure of a node, and we have a data variable and a pointer to left node and right node. And then coming to creation of a new node. So here we are creating a new node and allocating memory for it using malloc function, and assign data to a node's data part. And initially the node's left node and node's right node are assigned to null. Function to find the left height of a binary tree. So this function is to find the height of a left height of a binary tree. So initially the height is equal to 0. So while node, incrementing the height by 1. So the node's left node is assigned to node. So return height. And then this function is to find the right height of the binary tree. So again, initially the height is equal to 0, while node height, increment height by 1. When the node's right node is assigned to node. So return the height. Next, total node. So this function is to count the number of nodes in a binary tree. So if root is equal to null, that means return 0. Else we are assigning left height of a root to the LH and right height of a root to RH. And checking if the left and right heights are equal. If they are equal, that means return 2 to the power of height minus 1. Else we are having a recursive call. So we are calling a 1 plus total node function plus the total node. Coming to the main function, here we are assigning values to the node. So root node is holding a value 10, 15 is assigned to left node, 20 is assigned to root's right node, and 25 is assigned to root's left node's left node. And we have root's left node's right node is equal to 30, and root right's node left node is having 35, and root's right node's right node is having 40. So now it will print the total number of nodes in a tree. So let's check. So as you can see, the total number of nodes are 7. So here I have 2 bonus questions for you guys. Please try to find out the answers and let us know which data structure would you prefer to solve the problem statement. And the first question is, John has moved to a small village and likes visiting one of his best friends. He wants to take the shortest route because he is in a hurry to meet the best friend. So now he has decided to take the shortest path. John starts at intersection 1 and his friend is at intersection N. Each road links to an intersection from the start to its destination point. So, using which data structure would you solve this problem statement? And the second question is, let's consider there is a class of 25 students and we want to store the grades for each of their 5 courses. Is there a way we can keep all the information? Please let us know the solution for this question in the comment section below. So with this, we have come to the end of this session on the top 10 DSA interview question and answers. I hope this session was informative and interesting. If you have any queries regarding any of the topics covered in this session, then please feel free to let us know in the comment section below. And our team of experts will be happier to resolve all your queries at the earliest. Until next time, this is Sania from the Simplilearn team signing off. Thank you, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.